Hey everyone, hope you can hear me. We are back. You might have missed me for a week or so, I think. And before that, my colleague Benjamin has been doing a lot of our Frontend Love meetups. They usually took place on Thursdays, but we have decided to change things a little bit. So we are actually going to mix it up, and we're going to do daily sessions with Frontend Love. To provide you with daily sessions, tips, tricks, and the latest in JavaScript, we have invited people on a daily basis to discuss the latest and greatest within the JavaScript industry. For today, we have Maarten van Hoof. I will introduce him in a second. And you will also see my colleague Ben sharing tips and tricks throughout the week. We hope you enjoy it. We want to provide as much content as we can to our community, and well, enjoy the rest of today. Actually, welcome, Maarten. Hey, Maarten, how you doing?
Hi, everybody. Hey, how are you doing?
Very well. How are you?
I'm good. I'm a bit warm. It's good weather. So
Yeah,
we're heating up nicely here.
for sure. Not used to it, huh? Apparently, it's the last day in the Netherlands. That's going to be great. That's going to be great weather. We're both situated in the Netherlands, by the way, for the people that are watching from all over the world. But yeah, it's been exceptional good weather, to be honest.
It's been good weather. My plants are asking for rain though, so they'll be happy when the rain showers will be coming in.
Cool. Well, I don't want to hold anyone from your talk of today. Maarten is going to talk about OpenAPI. Maarten works for Isaac. You might have heard from Isaac before. We have collaborated on a conference before. Lucien Emmink, your colleague, has spoken for at our meetups and at our conference in Eindhoven, which we organized together with Isaac. So yeah, well, first of all, big thank you to Maarten, and big thank you to Isaac for supporting us with great content and with financial support as well. Please take it away, Maarten.
All right. So why OpenAPI? Why should we use the OpenAPI? Well, first of all, I'd like to challenge you, viewers, with a following question. Let's say we have to create a single-page application, and that single-page application is getting its data from multiple data sources, in this case, multiple REST APIs. But there's one big issue. The REST APIs aren't available anymore, or aren't available to us. What are we going to do? How are we going to solve this? Well, for the last year, I had this problem myself, and I solved it mostly using the OpenAPI specification. So like just said earlier, my name is Maarten, and I am a front-end developer at Isaac in Eindhoven. I'm also a Google mobile web specialist at Isaac. And at Isaac, we try to provide solutions for commerce and finance industries, businesses. Our motto is turning dot complexity into profitability. Oh my God, that's a hard sentence to say. But like it says, we try to solve complex problems, and building a single-page application without a data source that's available is a complex problem, and that's what we love. I'm going to give you a little high-level overview of the way we are used to communicating over HTTP, or the way of communicating over HTTP that I, at Isaac, have experience with. And the three big ones are SOAP, are REST APIs, and GraphQL. So what is SOAP? For the people who don't know SOAP, well, SOAP is a way of communicating over HTTP using XML-based request bodies and responses, mostly over post methods, and is mostly what I believe a backend focused framework or way of working, because it's been developed in the early 2000s when every website was actually server-side rendered. And so we had this monoliths where HTML was composed with strange interruptibility with other languages like PHP. Think MVC, Blaze. So the SOAP was a more backend focused language, and with the coming of the smartphone, with the popularity of the $.ajax method in jQuery, we started to do more things on the client, on the consumer side. And an easy way of, a more easy way of getting data into our client was using JSON. And from that popularity rose the RESTful API as we know it. But that wasn't enough. What if we had a complex application that sends a ton of data to our clients? Maybe the connections isn't that good, and it could impact performance. Well, in the early 2010s, the people at, I believe, Facebook started having this problem, and they came up with a solution called GraphQL, where the consumer decides which data he or she wants to receive from the data source. GraphQL is written in a own query language and will return a JSON object back to the consumer. And it's more a front-end focused or client-focused, consumer-focused way of communicating over HTTP. Now, enough history lesson. There's one major functionality in both SOAP and GraphQL that makes it possible to know upfront how the API works, what data goes in the API, and what data that comes out of the API. In the case of SOAP, it's a WDSL, a WSDL, and in the case of the GraphQL, we have a GraphQL schema that's defined in the GraphQL schema definition language, or SDL. Both are contracts to say, hey, I can receive this data, and this data can come out of me. Well, what do we have for the RESTful API? Well, over the course of many years, manual documentation was the way to go. We built our API and we documented it by hand. Well, there's a solution for that, to automate that, to opinionate that, and have a rigid framework in place. And that's called the OpenAPI. For people who don't know the OpenAPI, well, you might know Swagger, the predecessor of the OpenAPI. In the, I believe, late Lilies, as they are called, Swagger came to a rise together with the RESTful API. And the people who developed Swagger, of the Swagger specification, were like, okay, this is something potentially huge. We need to share this with the community. And so they did. They open sourced the specification, and now it lives under the flag of the Linux Foundation. Linux Foundation is a foundation that's maintained by the industry giants like Microsoft, Google, Facebook, and so on. And it lives under this the OpenAPI specification now lives under the same umbrella as, for instance, Kubernetes or Node.js. So the OpenAPI is a industry standard of defining your RESTful API. What's the purpose of the OpenAPI specification? Well, it defines a standard language-agnostic interface to RESTful APIs, which allow both humans and computers to discover and understand the capabilities of a service without access to source code, without access to documentation, or through network traffic inspection. So an OpenAPI document should allow both the user, developer, or computer to know what an API does and which data goes in and what data can come out. And when properly defined, a consumer can understand and interact with a remote service with a minimal amount of implementation logic. So the OpenAPI tries to serve its purpose by being something that we can build upon, that is a basis to build tools on, so we can more easily and more rapidly develop applications. I'm going to give you a little a high-level overview of this OpenAPI document, or an example of an OpenAPI document. There's lots to it, to the specification. The entire specification, if I go back, there's a link below. Specification is online on GitHub. It's open source. Is an active development. If you want to know all the details about it, you can check out the GitHub page. I'll put it in the show notes later. So, an OpenAPI document, how does it look? Well, first of all, we have to define what version API we're using. We're currently at version 3.0.2. For the people still using Swagger in their day-to-day workflow, that's more version 2. We like to use version 3 now because it's out for, I think, almost three years now. Well, that's where you define that version. You can also define general API metadata about the service you're exposing. You can define the servers, like base URLs, environments, and so on and so on. Maybe you have several environments like staging environment, development environment, production environment, local environment, I don't know. You can define it all there. Then, the first big part, the first important part of the OpenAPI specification, paths, where we define our endpoints, where we define our methods, our data that goes in through parameters or your parts of the dynamic parts of the URL, and where we define our statuses, what comes out, what MIME type comes out, and so on and so on. That's all called an operation. Then our components. The OpenAPI specification allows us to reuse parts of our data model throughout the entire application. And that's where we define those. We can define security mechanisms, like, for instance, maybe your user has to be logged in through the OpenID Connect protocol, or through a OAuth 2 protocol. We can define it right there. We can tag several parts of our OpenAPI document together. And if this piece of documentation does not suffice your needs, you can add links for additional external documentation. So now I will be talking about paths and components. Our paths are the places where we find our endpoints, like in this case, /pets and /pets/pet ID, which is a dynamic part of the URL. We'll define our methods, our HTTP methods, like get, post, patch, so on and so on. And we'll define our operations. An operation can look like this. You can define a summary. You can give it an operation ID, which you can use in other communication with your colleagues. You can tag. You can define parameters. You can define responses. You can give it a description. You can separately define a request body. For instance, when you do a post request, you have to give a request body with information. You can define other external documentation. You can flag it for deprecation, specific security mechanisms for this endpoint, specific service, and so on and so on. Like I said, every single detail is on the GitHub page of the OpenAPI specification. For this example, we have a query string parameter called limit, and it's not required. And we know that the query string parameter limit is of the type of a 32-bit integer. So here you see that both your front-end code and your back-end code, or your RESTful API, should interpret this query string as a 32-bit integer. And if it's not that, it should validate it and return an error. Keep that in mind. We can also define our responses. In this example, we have two types of responses: a 200 successful response and a default response. We can define each separate response if we wanted to, but if we only have one happy flow and all the rest are errors, we can define a specific status code and a default status code. And in this example, the 200 successful response will return JSON, and the format of the data that comes out of this endpoint will be in the format of that of a pets schema. And here we put a reference to our components section, to our data model abstraction. For default, we have a error, a reference to the error schema. We can also say that our application will return XML if we wanted to. And if it really rocks your boat, you can even define that you can return a text plain response. So first big part, paths, our endpoints, our methods, data goes in, data that comes out. Components, the abstraction of the data model within our document, so that we can reuse parts that are the same throughout our document. For instance, a pet or pets are generic responses, are request bodies, and maybe you'd also like to abstract headers like limit, offset, pagination. You can go into real details in defining those components and then reuse them throughout your document without cluttering it. For instance, a pet component can exist as an object and has the properties ID, name, image, tag in this example, which have their own types, which have their own specific formats, like ID, which is a 64-bit integer. You could also add custom extensions with prefixing the properties of a property with X-. This allows you to build certain extensions or certain scenarios that your API will react to. More examples on the GitHub page of the OpenAPI specification. You can also state which properties are required or not. And what I believe for us as JavaScript developers, a very important part, because then if the object isn't required, that comes back, well, we should use optional chaining or check if the property exists, maybe to hide certain DOM elements or not. Abstraction also means that we could reuse components in other components. In this case, the pets is an array of the pet component. We can also merge components together. We can also grab pieces of a component and put that in another one. We can put detailed components, objects in arrays, put strings in arrays, and so on and so on. It's very open for your solution. So let's take a step back and check our challenge again. So I started off with the question, how would you solve the following problem? You have to build a single page application. It has multiple data sources, RESTful APIs, but those REST APIs aren't available to you. How are we going to solve this? Oh, no, misery. Well, first, let's try to see if there's some documentation available so we can know what we can do, how we might talk to the API. The first RESTful API has this type of documentation, the other one has this one, the third one has this one, and the fourth one has this type of documentation. Now, if we were so lucky to always receive these beautifully formatted pieces of documentation, we should be happy developers. But I'm still not that happy with 4 different types of documentation, because my brain farts a lot and I hate context switching. It's a personal thing of mine. And when I have to context switch a lot, I lose time. So how could I gain time? Well, we just learned something new, a way to document our RESTful API. What if all pieces of documentation of RESTful APIs are written in the OpenAPI specification? Well, then I can put the document into Git, version it. If things change, I could use the Git diffs to see the changes. If I could put it into my favorite IDE and use the power of the IDE to fold different pieces together. Maybe I can use the advanced search functionality of my IDE to search the document. Maybe my IDE has extensions that allows me to empower me more and more. Well, this is how I gain time with talking to different RESTful APIs. So now we know what's in the RESTful API, but it's still not available to us. So we could write our code that talks to the API, but we'll not get a response back. So how are we going to solve that? Well, we might start mocking our RESTful API by writing our own, I don't know, Node.js Express server that takes a JSON file and serves that under a endpoint and a method. Well, that's not really handy because we have to do things manually. And a good developer is a lazy developer. So he shouldn't write that. Or she or he shouldn't write that. And these are real-world possibilities. So in this case, in my example, the API is non-existent, or the API is still work in progress, but for other cases, you might have a suboptimal connection, like if you're working on a plane or a train. Remember those days when we took the plane to a conference, to Frontend Love Amsterdam? That seems like ages ago. Well, like I said, a good developer is a lazy developer. So some people in at stoplights, they thought of this as well, and they said, well, we have this document in which we define our entire communication layer of a RESTful API. Well, why can't we just take that document and create a server from the information we have in there? And so they did. And they created Prism. And Prism is a tool that turns a OpenAPI document into a fully fledged server, RESTful API server, in a matter of seconds. It uses mocking, transformation. It validates the data that goes in. Like I said earlier, if you define that the data that has to come in is a 32-bit integer, well, Prism will validate on that piece of data. And if it's a string, it will return an error. Prism has saved me a ton of time over the past year in developing a front-end application fully separated from a backend. I've been developing this application nearly independently from the backend. I urge you to check out their GitHub page. I'll put the link in the show notes. The third thing and the last thing that I would like to talk about is, well, like I said, a good developer is a lazy developer. And I would like to talk about how we could communicate through our API. In this example, I've put a snippet of a Vue component that imports Redaxios, which is a Axios wrapper around the browser fetch API, and where we'll get a list of to-dos from a RESTful API on mount. We'll pass through a few URL search parameters, and we'll put the data from the response into the to-do. Well, this is nice and small and quite easy to take in. But what if our application becomes bigger and complexer? Well, this would be the ideal solution, because, like I said, our application is under full development. And what if things start to change? Like query string parameters, the requirement of certain query string parameters. What if endpoints or URLs change? What if the data model changes? Well, in that case, we'll have to check for errors and check if everything still works in tests, or in the worst case, in runtime. I mean, and in even the most worstest case, your clients will email you that your application is broken because you forgot a certain update on your API. We all may make mistakes. It's possible. Well, we have a document that says which data goes in and out of a service, and which is built up on a specified way. Well, what if we could translate that document into pieces of code? It would be awesome. And yes, it's possible. It's very much so possible. We could create our own custom SDKs from the an OpenAPI document. There's tools built to do that for us, like for instance the OpenAPI generator, or maybe autorests. To give you a clue how hard these tools are embraced by the community, I'm going to show you the list of client generators. So we are the generation of the client part that you will use in your consumer application. There's generators for C#. There's generators for Go, even for Flash, if you're really off the charts like that. If maybe you want to write a JavaScript generator, PHP, TypeScript, and so on. And it doesn't stop at client generators. It also has server generators. Because we have a total definition of the communication layer of a RESTful API, we can also render or generate that part of our server, and then hook up our business logic to that code-generated part. I can go back to my slide right now. Right, we're back. Cool. And you'll receive extra bonus points if you, as a front-end developer, are using TypeScript and a OpenAPI code generator. Because the OpenAPI document is typed, the data model is abstracted, and those abstractions can be one-on-one translated to interfaces and types that you can use throughout your application. If things change in your OpenAPI document and you regenerate that custom SDK, those changes will be reflected in the interfaces, in the methods that you will use throughout that application. So for instance, if a certain query string parameter that is translated to a method parameter in the SDK suddenly is required, and you have one instance in your code where that parameter wasn't passed through, well, at compile time, you will receive an error, and that you can fix that error then, and your clients, your users, won't see your application breaking. That's very cool. So, to round it off, what did we learn today? Well, we learned that the OpenAPI specification is a contract between services, that use the RESTful API way of working. It's a unified way of writing documentation. Because it's a specification, we can build tools on that specification, just like we build tools on the HTML specification and the ECMAScript specification. The tools that I love to use are automated mocking servers, like Prism, like custom SDK generators, and that all results in happy developers. And as we all know, happy developers result in happy project managers. And as we all know, happy project managers result in happy clients. Fine. Thank you very much for listening. I hope that you've learned something, and I could help you improve your day-to-day workflow. My socials are at mrthnvh.com and the same handle on Twitter. And if you like what you heard and you want to work together, give us a call at isaac.nl. So thank you to Frontend Love for giving me this opportunity to give my talk. And I wish you all a very peaceful next few days. Thank you.
Woo. Thanks, Maarten. Really great. Thank you very much.
With pleasure. With pleasure. Let me take it.
Great. Well, as said, we want to push out more daily content or multi-weekly content, however you say it in a proper way. So we will inform everybody about your talk and we'll inform the community about your talk. In the upcoming few weeks, we will publicize this in our newsletter. We hope that if people still have questions about your talk, that they can still reach out to you.
Yeah, certainly. Like they can reach out to me on email or on Twitter, everything on GitHub if you like. Everything's up on the website.
Nice. Yeah, we'll probably collect all of the talks in a dev.to article.
Yeah.
So we're actually making decisions right now. We're trying a few things here and there, see what people really like, whatever works best for them. Because, well, nowadays they're also overflooded by content, of course. So we want to keep it as educating for everyone. And I for sure think that your talk has contributed to that today.
Yeah, it's for me, it was a real revelation to learn about this OpenAPI. That's why I'm so passionate to talk about it, because for the 6-7 years I've been working as a front-end developer, I never really got to know the benefits of that OpenAPI specification. And I noticed that in the front-end community, most developers also do not realize the real benefits of the OpenAPI specification. Whereas it can save a ton of time and help you sleep a lot better at night. So that's why I'm eager to share this knowledge with everybody.
You can for sure hear the passion from the story. No doubt about that. No, it's really great. I do think for you this was also relatively new then, or when was this something you really got into?
Well, it started when I started at Isaac a year ago, where I was working at a smaller company at first, where there wasn't really a need for these complex contracts to be stated between developers, because we were like with 6 people. And now with Isaac, we're constantly growing, and new developers come into projects, and we need to get them up to speed real fast about, well, what are the capabilities of an API? Well, instead of taking time to write documentation, we'll let the backend or the RESTful APIs colleagues generate a document, and then the front-end developers can go on developing their application to that document.
Yeah,
it's also handy for instance, when you're working with another company, when another company is taking on the RESTful API and you have to build your front-end application or even mobile application. It's the contract between the two parties in which you find this data goes in, this data goes out, and it saves a ton of time and it saves a ton of discussion.
There's just a lot more clarity and guideline around it.
Yes.
Yeah. Well, as you said, right? Happy project manager, happy developer,
happy clients, and that's what we're all about, right?
Yeah, but I can imagine once the parameters for everybody are are clear, especially also maybe from a non-technical perspective. that's where it becomes really enjoyable for the whole team.
Yeah. It's well defined, and because it's a specification, we can use tools to enhance our day-to-day workflows.
Yeah.
So things get moving more quickly. Even so, to give a real-world example, I was working independently from a non-existing RESTful API for the last half year.
Yeah.
And a few weeks ago, the integration part came, and there were no issues at all concerning integration because we had that document.
Yeah.
And I worked on that via that mocking server and via code generation. So when things started to change, things were changed really fast, and we could pick up the pace of keep up the pace very very good, very well.
Nice hearing you talking about it, at least. Well, once again, Maarten, thank you very much.
My pleasure.
Isaac, once again, thank you very much for being so supportive of everything we do. I know that maybe not everything you talk about is in the name of Isaac, but I do think that they deserve a special thank you.
Wow.
And we hope to stay in touch again for the future. If people have any questions, they can reach out to you via Twitter or via your website. What was it again? Sorry, can we put it on?
It's my. Whoa, let's go back a little slide. Okay, well, it's mrtnvh.com. It's my name without syllables, and at the same Twitter handle, and all the links to GitHub and other LinkedIn pages are on my website.
Right.
And if you like to work with me someday, then you'll have to hit up my partners at Isaac.
Great. Well, thank you, Maarten. Hope to talk to you soon.
Hopefully, I will. Okay. Goodbye.
See you.